Our design idea is polymer recovery from textile recycling, weaving a new life cycle. The members of the group are Samia, Leah, Riley, Madeline, and Zoe. Clothes we wear every day are made up of cotton polyester blended fabrics that result in tons of clothes entering waste streams and contributes to a growing plastic crisis. The plastic in our clothes builds up in landfill spaces without ever degrading. Today, clothing waste alone counts for 7% of plastic waste in landfills. As we continue to buy more clothes, the consequences are becoming more expensive and more environmentally damaging. Year, 85% of textile waste ends up in landfills or is incinerated. That's the equivalent of one garbage truck full of textiles being discarded every second. Polyester, a plastic-based fiber, shreds microplastics into our oceans. And it's not just waste. Producing a single t-shirt takes 2,700 liters of water, enough for one person to drink for nearly 3 years. By recycling textiles, we can significantly reduce landfill waste, conserve water, and lower our carbon footprint. It's time to rethink how we handle textile waste. What's our solution? We're designing a chemical separation process for cellulose from clothing using sodium hydroxide and urea solvent to recover and reuse cellulose and polyester as raw materials. Textile waste is first collected and sorted, then the waste is shredded and buttons and zippers are removed. Using solvent, the waste is made into a slurry and the cellulose is separated out. Separated cellulose and polyester can be made into things like pulp and pellets and be sold off as raw materials. Our process uses the solvent to break down the hydrogen bonds in cotton fibers. This causes the cotton to dissolve while the polyester remains intact. The dissolved cotton is then recovered as cellulose, which can be reprocessed into new fibers. Meanwhile, the remaining polyester can be collected and turned into pellets for reuse. The first step is to verify the solvent works well to dissolve the cotton from the polyester in our sample textiles. We test this process on a variety of compositions of cotton polyester blended clothing. Second step is to create an upscaled process design using the lab results. We are designing this process with real-life equipment using modeling software. The goal is to implement this upscaled design in a textile company's production process. We aim to work with a company like Gildan that makes many polyester cotton blended textiles that are used in single-use events. Our solution helps close the loop in the textile industry by giving new life to discarded fabrics. Instead of burning or landfilling textile waste, our chemical recycling process is a safer alternative to the harsh, toxic chemicals often used in recycling. This means fewer emissions, less pollution, and a more sustainable way to recover valuable materials. By efficiently separating polyester and cotton, we reduce waste and move towards a circular economy, where textiles are reused instead of discarded. Additionally, the recovered cellulose has the potential to be repurposed for biofuels, food fillers, and more, expanding its application beyond just textiles.